Okay. So we are looking at how we are going to perform operations on complex numbers today. So this is something, if you came out of Algebra 2, you know what you're doing. If you came out of geometry, you have absolutely no clue about this, okay? It's something brand new, all right? It's pretty easy. You have to kind of take my word for this beginning part, all right? And then after that, once you kind of learn the pattern, it's actually a pretty easy thing, okay? And it's actually kind of fun. This is one of my more favorite ones. Okay, here's a pattern. I'm going to give you a new letter. In math, letters are used for certain things. We use X's, Y's, Z's, A, B, C's as variables. Notice I is very rarely used for anything. It's because it stands for a complex number or an imaginary number. Okay, so the I to the first is just I, but here's the weird one. Okay, I squared is equal to -1. We're going to base everything else off of that, okay? So I squared is equal to -1. So let's think about that. If I is 1 and I squared is -1, this I cubed could be I squared times I, right? Couldn't I sub a -1 in for that? So -1I or just -I. Okay, let's think about I to the fourth. How could I split up I to the fourth? I squared times I squared. That works. I could do I cubed times I, either one. What is I squared? What can we sub in for it? -1 times -1, and we're going to get what? 1. Okay, now let's look at this pattern. Let's keep going and see if we can establish a pattern. Okay? All right. I to the fourth times I. Can we use that? Yeah, so what's I to the fourth? What did we establish I to the fourth as? 1 times I would just be I. Okay? I to the fourth times what? I to the second. We know I to the fourth is 1. What's I squared? So what's this equal to? -1. I know this seems weird right now, right? It's okay. It's supposed to. I to the fourth times I what? Cubed. I to the fourth is 1. What's I cubed? -I is what we said, so it would be -I. All right. I to the fourth times I to the fourth equals, what's I to the fourth? 1 times 1 is? Do you see how it cycled back? So what do you think I to the ninth would be without doing any work? I. What would I to the 10th be without doing any work? The problem is what happens if we go to like I to the 50th? We don't want to have to cycle through all that, right? So there's got to be a way to do it. So I'm going to show you how to do that here in a minute. Okay, fill in all those blanks for me, please. All right. So imaginary numbers is the answer to a problem with an imaginary solution should never have an I with an exponent greater than 1. Okay? If you have an answer with an I with an exponent larger than 1, divide the exponent by 4. The remainder will be 0, 1, 2, or 3. Okay, so this is how we're going to deal with this when it cycles, and maybe it's up at 50 or something like that, okay? If the remainder is 0, replace the I piece with, or replace the I with 1, with I, with, with -1, and with -I. So those are the 4 things that we cycled through in the pattern, right? All right. Let's try these first few here, okay? Notice they're short. They all fit on one slide, right? So they're short. So we've got I to the 50th. So what I'm going to do is I'm going to divide that 50 by 4. So how many times does 4 go into 5? Once, right? We subtract, let's see. We've got 10. How many times does 4 go into 10?
2.
2. Multiply that out. What would your remainder be? Remainder is 2. So that's the same as saying I to the second, what's I to the second? -1. Okay. All right, let's try 29. Do I care about this answer here?
No.
I only care about that remainder answer. So I'm dividing 29 by 4. How many times does 4 go into 29? 7. What's left over? 1. Remainder 1. So that means this is the same as I to the first. The remainder goes there. What's I to the first is just I, isn't it? Okay. Let's try example 3. 132. 4 goes into what? 13 how many times? 3. So you got 12. How many times does 4 go into 12? 3. Is there a remainder this time? No. Remainder is 0. So I to the 0. What's anything to the 0 power? 1. So see, at that chart right there, some of the other teachers do. I just do it with the exponents, okay? I memorize the squared and the cubed and the... Okay, let's do one more together, and then I'm going to have you do the last 2 on your own, okay? So 151, how many times does 4 go into 15? 3, okay? So we've got 12, right? So 15 minus 12 is what?
31.
So 31. How many times does 4 go into 31? 7 again. So what's your remainder going to be? 3, right? So this is the same as I cubed. What's the name for I cubed? -I. All right, I want you to try example 5 and example 6. Okay? All right. How many times does 4 go into 25, everybody? 6. So we've got 24. All right. 25 minus 24 is what? 1. So we've got 16. How many times does 4 go into 16? Remainder is going to be what? 0. Did I have to do all the work? All I care about is that remainder, right? So this is same as I to the 0. What's anything to the 0 power? 1. Perfect. All right. 4 goes into 16. 4 times, so that's just 0, right? Bring down the 7. How many times does 4 go into 7? 1. Once. Okay, so let's see. What's your remainder on this one? 3. Remainder 3, which means I have I to the third. What's I to the third? -I. Okay, so let's get the weird. Let's keep continuing the weirdness. Okay. All right. So a little bit more. Notice they must not be that hard if we're throwing them all on the same page, right? Here we're going to do some combining like terms, right? So let's do our combining like terms. Before I do that though, I got to get these into, I got to simplify the i's. Okay. So I cubed is the same as what? So this is the same, would be the same as negative 3i. What's I squared the same as? Negative 1. I to the 9th, wouldn't I have to divide it real quick? So how many times does 4 go into 9? 2. So we'd have 8. What's your remainder? 1. So that's the same as I. So plus 16i. What's negative 5 times negative 1? 5. And then we can combine these i's together. So negative 3i and positive 16i is... Notice I wrote the variable in the back, right? We're going to see in a minute that's the proper way to write a complex number. Okay? All right, I'm going to do this the long way. Then I'm going to show you the shortcut. Okay? Let's see. This was probably still first semester last year, so if you've had Mrs. Artifer, she stole her little saying from me. Okay? If she used the saying. All right, so I'm going to rewrite that as negative 1 times 25. Or the square root of negative 1 times the square root of 25. Go back to what we had here earlier on the first slide here. Let me go to, nope, where is it? Go to slide 2, okay? I know that I can replace negative 1 with what? I squared. Okay, so I'm showing you the development of this, and then we're going to take a shortcut for the rest of it. So I'm going to put an I squared in there instead of negative 1. What's the square root of I squared? I. What's the square root of 25? 5. So the answer to that one is 5i, but that's way more work than I want to do. Okay? So here's what you're going to do, and you might want to write this out in the left-hand column. See a negative under a square root, pluck your eyes out. Got it? Pluck your eyes out. It's kind of gross, but it works. They don't have the eyeball candy out this time of year, so you get a little sticker eyeball. Put in your nose. Stick it right in there in your nose. Okay? So you'll remember it. Okay? Pluck your eyes out. It's too early for Halloween yet. I forgot last year to buy the candy and then have it saved for you guys. Okay, so take one, pass it down, put the little sticker in your notes to remember that that means pluck your eyes out. Okay, so let's take the shortcut on the next one. All right. So when I see a negative under a radical, what do? What did we just say? It sounds weird. Let's say pluck your eyes out. What's the square root of 49?
7.
7. Done. Nice shortcut, right?
Yeah.
All right. When I see a negative under a radical, what do we got to do? Pluck your eyes out. So I'm going to take out that I. But I can't just write the 12, right? Or I can't just take the square root of 12. But there is the square root of 12, I can simplify that radical. So we're reviewing our simplifying radicals right now. What square number divides 12? Do you remember the square numbers? They're up there at the front of the room. We skip 1. Does 4 go into 12? Yes or no? Yes. So I put my square number up here. What's left over? 3. So you want to take to use this, you want to take the biggest square number and put it in the first box. What's the square root of 4? 2. So the way we would write this is 2i squared of 3. All right. Example 11. This is my favorite number, the square root of 98. I'm not sure why, it just is. Okay. So when you see a negative under the radical sign, what do? Pluck your eyes out. Okay, now we're going to go down our square number list. Okay. Does 4 divide 98? Yes? No? No? Okay. If you have your phone and you want to get that out for the calculator on it, that's fine. Okay, you can do that. What we're looking for is it to go in there pretty. Okay, we didn't grab the calculators today. Does 9 divide 98? No, divide 99, right? What about 16? Do you see where I'm going down the square number list and trying to divide them in? 16 divide 98. No. 25? No. 36? No. What about 49? Yeah, how many times? 2. Okay, so 49 times 2 is 98. Probably can guarantee you're going to see 98 on the test somewhere. Okay? All right, square root of 49 is? 7i square root of 2. All right, I want you to try 12 on your own. Actually, do 12 and 13. These are nice square ones. Okay? Try 12 and 13. All right, when we see a negative under a radical, what do? Pluck your eyes out. Biggest square number that goes into 75. I gave you an easy one, right? Big, and what's left over? 3. Square root of 25 is? 5i square root of 3. Radicals shouldn't be a big deal. You did them last year in geometry, right? You did them in Algebra 2 if you were there. You did them in Algebra 1. So we don't teach a whole lot of radicals. That was your radical review right there. All right. See a negative under a radical, what do we get? Pluck your eyes out. Square root of 16 is? Square root of 25? 5. Okay? We good? All right. All right. Okay, go ahead and fill in the blanks. Oh, wait. Is that even on there? Oh, yeah, it is. Okay. All right, we got it. All right, so definition of a complex number, and I was writing it in the funky order where I put the number and then the I at the back. A complex number is any number that can be written in the form a plus bi, where a and b are real numbers, I is the imaginary part, a is called the real part, and I is called the imaginary part. The piece with the I always comes last, okay? So when we do operations with complex numbers, to add them, add the real parts, add the imaginary parts. All it is combining like terms like we would with any variable, okay? But first, we might need to get it into i's with no exponents, okay? So we convert it first. To multiply complex numbers, distribute or use FOIL. Once you have done this, replace any I squareds with -1 and simplify, okay? Oh, that part wasn't on there, was it? That's okay. Don't worry about it. It will come to us because you're just going to follow your normal rules. Okay. All right. So let's do some. Again, they're all squished onto one slide. It must not be that difficult. Okay. So what is the? So we're adding it up, right? So what's 8 plus 2? 10. Do I really need the parentheses on this thing? No. So 10. Let's see. -5i and +i. Do we agree with 4i? -4i. All right, I'm going to go down and let's do the odd ones, and I'm going to have you go back and do the even ones, okay? So let's do the odd ones first. Well, maybe. We'll do these two odd ones. How's that? What are we going to do with this negative here? Distribute it. So I'd have 4 plus 7i minus 2 minus 3i. Okay, combining our like terms. What's 4 minus 2? 2. 7i minus 3i. 4i. All right, everybody do 14 and 16. So just do 14 and 16. They're numbered wrong on the paper?
Yeah.
What happened? 14. Oh, they're numbered wrong in my PowerPoint. It's okay. So we're doing the even ones, not the odd ones, right? I didn't update the PowerPoint. So 14, 16, is that better? 18, 19, 20, 21. We must, you know what probably happened? We added one in and I didn't update somewhere. Okay. So, let's talk about these. We're combining like terms. Do I really need the parentheses? No. So what's 4 plus 5? 9. 2i minus 7i. Negative 5i. What do we need to do here first, everybody? Distribute it. So I'm at 9 minus 6i minus 3 minus 5i. So it's 9 minus 3. 6. Negative 6i and negative 5i. Negative 11i. All right. We good?
Someone has a question.
Yeah, what's wrong? Oh, sorry, what's wrong?
Does the negative get distributed to the negative 5i?
Yes. Anything inside the parentheses.
It just make it
Yeah, we need to make it a
Oh, it makes it, sorry, blonde moment. So it would just be what?
1.
Thank you for catching that. Negative I. There you go. Did I answer everybody's questions? Yeah, it's really good when the teacher messes up. It happens. Today I'm going to blame it on the summer cold that I have, okay? All right, let's look at 18 and 19 together, and then I'm going to have you do 20 and 21. So what do I have to do on this? Notice it changed. What's my operation now?
Multiplying.
Multiplying. So what do I have to do? Foil, okay? So what is 3 times 5?
15.
15. Okay, 3 times negative I.
negative 3i.
Good. I times 5.
5i.
5i. I times negative I.
I squared.
Negative I squared. What is I squared better known as? What did we talk about earlier in the lesson? So what am I going to do to this? It's negative times negative 1. What's that going to turn into?
1.
Positive 1. So y'all say it's better known as, and we flip the sign and we change it to a 1. Okay? So now I can combine my like terms. See what happened? That got rid of the I squared for us, and we can combine our like terms. So it's 15 plus 1. 16. Negative 3i and positive 5i. Positive 2i. All right. I'm multiplying here, but do I need to FOIL on 19? What are we going to do? We're distributing. Okay, so what's 4i times negative 6?
Negative 24i.
Negative 24i. 4i times I.
4i squared.
4i squared. So that would be better known as what number?
Negative 4.
Good. So the I squared acts like negative 1 in your head. Multiply that by the number, right? So basically, what are you doing to the sign of the number? Switching it. Is this written in the right order? We want to put the number up front and the imaginary part in the back. This is one time where I may mark that down if it's not in the right order. All right, everybody try 20 and 21 right now. Okay? Let me see where we're at here. and then you're just going to check negative. All right. I know I'm going to, even if you're not done, look up here. Did I do that first line right? Double check my arithmetic. It's not good sometimes. All right. What is this better known as at the back here? 14. Negative 36 and positive 14 is?
Negative 22.
All right. 63 and 8 is?
71.
71i. Okay. All right. What is this? Do you agree with my 21 so far?
Yeah.
Okay. What is that going to be better known as? Positive 1, because we got negative 1, negative times I, negative 1 from the I squared would turn into positive 1, so we'd write 1 plus 9i. Okay, let's keep going to the next part. I'm going to skip around a little bit because I want to make sure we get enough in so you guys can do the homework, okay? All right, we got to solve. What am I going to do to move the 36? Subtract it. So in the past, you've been told you can't do a negative under a radical, right? We changed that today. What am I going to do to move the 4? Divide it. What do we get? 36 divided by 4 is negative what? 9. How do I undo this squared? Square root. Technically, we got to write a plus minus out front, right? When I see a negative under a radical sign, what do we do? What did we learn today? Pluck your eyes out. What's the square root of 9? 3. Is that the only difference between that and what we've been doing is the I, right? We okay on that? So you should be able to solve any of them. On this one here, when we move this over on the 72, we're gonna have to split it up, right? Oops, sorry. I comes out. What's 72 break into? What's the biggest square number that goes into 72? Do we know? People mess this one up all the time. 9 and 8 do not, that's not the biggest. What's bigger than 9 that goes in there?
31. I mean 36.
36, how many times? 2. So we'd have 6i squared root of 2. Oh, plus or minus, right? I missed my plus or minus. All right, I'm going to keep going because the other stuff is more important than this stuff. All right, fill in those blanks really fast. I know we need to be getting to cleaning up here. I'm going to try 26 and 28, and that should be enough for us to be able to do the homework, okay? There's a lot of stuff there that isn't here, huh? We simplified it. The complex conjugate of a plus bi is this, so don't worry about this piece, okay? There should not be any, it's this one here, i's left in the denominator. Okay, so there wasn't much to write. So here's the deal. Complex conjugate. A conjugate just means that we're gonna switch the sign in the middle. Okay. We don't want. It's like having a radical in the denominator. We're not allowed to have i's in the denominator. So we use the conjugate to get rid of them. So what's the conjugate of this thing? Switch the sign in the middle. 3 plus 5i. Okay. Here's what happens. I'm going to show you a shortcut. 3 times 3 is what? 9. 3 times 5i is what? 15i. Negative 5i times 3 is? Negative 15i. Negative 5i times 5i is negative what? Better known as positive 25. What happens to this middle part? Cancels. I'm left with 9 plus 25, which is what? 34. Here's the thing. Every time we do a conjugate, it's always going to cancel the middle. So rather than doing FOIL, I'm only going to do first and last because the O and the I will always cancel. All right, let's talk about 28. So I'm going to multiply by the conjugate of the denominator. What's the conjugate of the denominator? 3 plus 2i. Okay. On the top, I need to FOIL. So I'm going to FOIL the top. So what's 5 times 3? 15. 5 times 2i. 10i. Good. 2i times 3. 6i. 2i times 2i is 4i squared, better known as -4. Swap the sign. Leave space for the denominator, and let's finish the top. What's 15 minus 4? 11. 10i plus 6i. 16i. Good. All right, on the bottom, I have conjugates, right? Shortcut on conjugates is I only multiply the first and the last. So what's 3 times 3? 9. Negative 2i times 2i is negative what? 4i squared, better known as positive 4. 9 plus 4 is? So do you see how I cut out the middleman there? Literally, I cut out O and I on FOIL. Okay. All right. I'm going to flash the haiku up there. It is in haiku. Okay.